Hey, are you curious about the periodic table? Especially aspects such as atomic radius, ionization energy, and metallic character? No? Alright. Let's start with atomic radius. Atomic radius is the size of an atom, including the electrons and their orbits. Across the periodic table from left to right, it increases in size, but as it goes down the periodic table, it increases greatly in size. Mainly because of the fact that there's much more shells. Not that kind of shell, this kind of shell, for electrons to go around. As for ionization energy, it's a measure of how easily electrons can be removed. The farther right it is on the periodic table, the harder it is to remove the electrons, meaning that it requires more energy in order to remove them. As you go down the periodic table, it requires less energy to remove electrons. It would be harder to remove an electron from chlorine than it would be to remove an electron from, let's say, lithium. Milky point is a threshold that when elements pass that temperature, they will liquefy. Normally, Milky point lowers as it... Generally, the Milky point lowers as it goes more right on the periodic table. However, as it goes downwards, there is no trend though. Notice how I said generally earlier, voice crack. Notice how I said generally earlier on? That's because there are a few exceptions, such as Mercury and carbon. Mercury having a really low melting point, and carbon having a very high melting point. Next, I would go on to metal reactivity. However, I still need to talk about another thing that relates to metal reactivity. Roll the clip! Electronegativity. It refers to the strength of atoms attracting electrons from other atoms. From left to right on the periodic table, there's an increase in electronegativity. But as it goes down the periodic table, there's a decrease in electronegativity. This is because of electron shielding. For those who don't know what electron shielding is, it's basically similar to that of two magnets with both negative forces pushing against each other. It means that some of the electrons from the atom is pushing away the valence electrons or farther away electrons from the atom itself. However, I don't think this applies as much to the noble gases because they already have a full valence shell. Anyways, back onto metal reactivity. It's basically a combination of electronegativity and ionization energy. On the periodic table, as it moves right, reactivity decreases though, because we start moving towards the transition metals, the metalloids, and then the nonmetals. However, as it moves downwards on the periodic table, the reactivity increases though. How about some conductivity? It's the ability of how well atoms conduct valence electrons or loose electrons. Think of your phone, for example. What do you think is powering it? Those loose electrons right there. Conducting along the metal, of course. Not along any other non-metal, of course. If it were conducting along the non-metal, it would be shocking your hand right. Painful and imagine all the lawsuits at hand for all these injuries too. All you'd hear is F-bomb, pain of it. I'm rambling on, aren't I? Upon the periodic table, as the elements move right, the conductivity increases, however until it reaches metalloids. After that, it starts to decrease. And then there's no trend going downwards. Next, I'm going to tackle two topics here, metallic character and non-metallic character. Metallic character refers to the level of reactivity of a metal, while non-metallic character respectively refers to the level of reactivity of nonmetals. They're both essentially opposites on the periodic table, with metallic character decreasing as it goes right on the periodic table, while non-metallic character increasing as it goes right. There's more metallic character as the periodic table goes downwards. However, there's less non-metallic character as the list goes downwards as well. Oh, that's right. I forgot to mention a few things from earlier as well. Ever wondered how the elements on the periodic table were ordered? It's based on their average mass. For example, take lithium. Its mass 6.9 is heavier than helium, which is 4.0, but is lighter than beryllium, which happens to be 9.0. I also forgot to mention where the metals, nonmetals, and metalloids are too. For example, the metals start here and then end right here, which is where the metalloids start, and then the nonmetals start right here. To branch off from that, there's certain families, such as the alkali metals, there's the alkaline earth metals, the halogens, the noble gases, and then all the transition metals. Alkali metals are highly reactive and they all have a charge of +1. Alkali earth metals have a charge of +2 and are very reactive, just less reactive than the alkali metals. Transition metals can conduct very well, they have a lower melting point, and their ion charges are varied. The halogens are basically the nonmetal alkali metals. And what I'm trying to say is that they're very reactive nonmetals. Alone, they're known as a gas, and they all have a charge of -1. Noble gases are, well, gases, and they all have a charge of 0 because they already have a full valence shell. Not only that though, but they're highly unreactive. Unless they're under extreme conditions, they will not react.